Thank you for joining us today for our webinar. My name is Rachel Schnitt, and I'm a communications officer with Canadian Nuclear Laboratories. And today we are doing a webinar on the Douglas Point facility. So before we get started, I would like to acknowledge that the Douglas Point facility is located on the unceded and unsurrendered territory of the Saugeen Ojibwe Nation and the traditional lands of the Georgian Bay Métis Nation of Ontario and the historic Saugeen Métis peoples. As an organization, CNL recognizes and appreciates their connection to this land, and CNL also recognizes the contributions that First Nations, Métis, Inuit, and other Indigenous peoples have made both in shaping and strengthening this community, this province, and this country as a whole. So today we'll be providing an update on the Douglas Point reactor decommissioning. This will include a little bit of a refresher on the project since it's been a while since we've done a webinar on Douglas Point. I'll go over a few housekeeping details before we begin for those of you who aren't familiar with our webinars. So there is simultaneous interpretation available for the webinar. You can access this in the toolbar at the bottom of your Zoom. It's the globe icon. Select a language you'd like to hear, and please note there's a slight lag in translation. Today's session is planned for about an hour, and we anticipate the presentation will take about 30 minutes, and then the rest of the, oh no, sorry, the lights went off in my room. And the rest of the
We can still see you.
Okay, and the rest of the time will be Q&A. To ask a question to be answered during our Q&A portion, you can use the Q&A button, again, on the bottom of your toolbar in Zoom. We'll be responding to the questions following the presentation, and any questions that we don't get to during the session, we will follow up with in writing after the session has finished. Please note that these sessions are recorded and we'll be posting them in French and English to our YouTube channel. If you're having any questions, or if you have any technical issues during the webinar or have a follow-up question after, and you'd like to chat further outside of this, please email us at ermstakeholder@cnl.ca. Our team is watching the inbox, so if you're having any issues, we'll get you sorted out. So I will pass it over now to Julie to introduce herself, and she's going to kick off our presentation today.
Thank you. You can go to the next slide. There we go. So good morning, everyone. So my colleague Joe Holstead and I will be presenting today an update on the Douglas Point Waste Facility. Can you please move on to the next slide? Yeah, so good morning. Julie Terrien, I'm the Facility Authority and Operations Manager at the Douglas Point site. And I would like to reiterate Rachel's point. Thank you very much for participating today at our second webinar for the Douglas Point Waste Facility on specifically the decommissioning project of the facility. The first webinar took place back in September of 2020, and it is still available on the CNL website. So if there's like background information you would like, some of it is in that previous webinar that we had. So today we'll be covering the history of the Douglas Point Nuclear Generation Station. Then we'll be talking about the decommissioning project and then the upcoming work. As you can see on the pictures of the slides, you know, the Douglas Point now and then. So we have a team that has been maintaining the site in a very good condition. You can see that the shrubs have grown, but the rest of the facility still kind of looks the same as it was a while back. Next slide, please, Rachel. So some of you may wonder, where is Douglas Point? So Douglas Point is located in the municipality of Kincardine in the Bruce County in Ontario. It's on the Lake Huron side, and you can see it on the color picture in the middle of the slide. The Douglas Point site is owned by Atomic Energy of Canada Limited, ACL, and it is operated by Canadian Nuclear Lab, CNL. It's located enclosed within the Bruce site. So Bruce A, Bruce B. You can see the picture on the right. It'll show you a small footprint in the red box. That is where Douglas Point is, and the rest of the site is the Bruce site. So Douglas Point occupies a really small portion of this area. Next slide, please. Douglas Point Nuclear Generating Station was Canada's first full-scale nuclear power plant. It was a joint project between Atomic Energy of Canada Limited as an owner and Ontario Hydro, now Ontario Power Generation, as an operator. It was a 200 megawatt CANDU, and it ran from 1967 until 1984, where it was permanently shut down, having achieved its objective. As a prototype reactor, Douglas Point demonstrated that CANDU nuclear plant could be scaled up for commercial power generation. And that's a legacy that helped Ontario to get where we're at today with consistently more than half our energy coming from clean, reliable, low-cost nuclear power. Next slide, please. Thank you. So this slide shows an overview of the life cycle of the facility. As you can see from the left to the right, the construction operation phase was from 1960 to 1984. Then the facility was put into the first phase of decommissioning. The first phase of decommissioning is a phase where the reactor was shut down and the systems were put in safe state. Then we entered the phase two decommissioning. The phase two decommissioning is the storage and surveillance phase, where the critical systems and structures are maintained over a period of time, and this allows for the radioactive materials to decay. And then the phase three decommissioning, which is more of a decommissioning and demolition stage, which is the stage where we're at for the Douglas Point site. So we can find this diagram on our CNL website also, so cnl.ca/DouglasDP. And I will go a little bit further into the phase three decommissioning in the next few slides. So now let's talk about the decommissioning project in a little bit more detail. So the Douglas Point decommissioning plan is to remove the entire facility by 2070. And of course, conducting engagement and incorporating the inputs from the public and the Indigenous community throughout this entire process is critical for the success of this plan. So the plan is to execute the phase three decommissioning, like I mentioned, the demolition and the decommissioning and demolition portion. And it's broken down into 5 planning envelope or 5 grouping of buildings. So the first grouping of buildings that we have is the non-nuclear buildings, which includes the turbine building and the administrative building. And I'll get into a little bit more details of each of the little planning envelope here. The second one is the nuclear buildings, including service building and purification building. The third planning envelope is the reactor building peripheral equipment, which we call the clear out. And then the reactor building and the reactor core and bioshield. And lastly, the spent fuel canister area. So let's get into a little bit of detail of each of these planning envelope, just to give a little bit of context. And just so you're aware, in the webinar back in September of 2020, there's like more pictures on every one of those facilities that I'm going to describe. So if that is of interest to you, please go and watch the previous webinar. So the non-nuclear building, so as you can see clearly, there's a large rectangular building that's called the turbine building. So that's included in the non-nuclear building. There's also an administrative building, which was offices back when this was the facility was in operation. So those structures do not contain any nuclear material, and it will be, once we get into the demo phase, it'll be more of a conventional industrial decommissioning and demolition. So CNL has obtained approvals from the Canadian Nuclear Safety Commission, the CNSC, to start the decommissioning of these structures via the approval of what we called a detailed decommissioning plan. The second planning envelope is the nuclear building, so which include the surface building and other smaller size building. In this picture, you can see the roof of the surface building, which would be on the left of the large turbine building. So you can see a flat surface, that is the roof of the surface building. So those buildings were necessary to support the reactor operation. They do contain some contaminated material and hazardous material. The detailed decommissioning plan for these buildings was submitted to the CNSC last March for their review and approval. The third planning envelope is the reactor building clear out. So the reactor is the large structure that you can see on the picture with the white dome. So the clear out of all the material covered by this plan is the equipment that are within the reactor building that are not part of the reactor core or bioshield. So CNL is planning to progress the detailed decommissioning plan for the execution of that work in the coming year, and we'll be submitting that to the CNSC for their review and approval again. The fourth and fifth planning envelope, so the reactor building and the core and the spent fuel canister area, is outside of our current decommissioning license for the Douglas Point site. CNL, though, is continuing to develop the plans on how these structures will be decommissioned in the future. So just to note, the core and the bioshield, just for your awareness, the core and the bioshield of the reactor is kind of within a box in the nuclear, in the reactor, and this is where the nuclear reaction would take place. And the spent fuel, just for your information again, is the fuel that we put it in the core, and once it had reached its end of life, we would store it into the spent fuel canister area. And I can show you in the picture, the spent fuel canister area is kind of the smaller structure. Thank you, Rachel, for pointing it out. It's the smaller cylinder with the white caps at the bottom of the picture. And all waste generated during the entire decommissioning of the facility, of course, will be characterized, will be managed according to type, including industrial reuse and recycle, which is a policy of CNL. Next slide, please. Thank you. So just to give you a little bit of a timeline of our plans with regards to the execution of those planning envelope that I was just describing. So you can see the non-nuclear buildings beginning 2021 and finishing in 2025. And my colleague Joel Holstad will provide you with an update of where we're at with this. The nuclear building, which includes, purification buildings, surface building, all the buildings that were outside of the reactor, but there to support the reactor operation. So we're planning to do some work 2022 to 2025. The reactor building clear out, which is the next one up is 2024 till 2030. And once again, my colleague Joe will provide a further update on this. As you can see, the reactor core, the reactor building in the spent fuel canister area is outside of our license period, so therefore outside of after 2030. And once again, this diagram is available on our CNL website. Rachel, can you go to the next slide, please? So I was talking about waste that we will be generating. So yes, there will be a lot of different types of waste that we will generate. The first one that I would like to talk about is the clearable waste, so non-radiological, non-hazardous waste, the likes of concrete, steel, miscellaneous construction material. So CNL expect that 90% of the clearable waste will be reused or recycled, and the outstanding volume will be sent to conventional landfill. We'll also be generating designated substance. As you're aware, those are older building and they do contain asbestos. So we are working really hard at removing that hazard from the facility. We also have some PCB ballast that we have in the facility that we need to remove. And those will be disposed in licensed disposals facility for hazardous material. We'll be generating low-level radioactive waste and intermediate level radioactive waste. The low-level radioactive waste include the likes of contaminated soil, PPE&C that the workers would have worn to do some of the work, and some other lightly contaminated metals. The intermediate level radioactive waste are some of the legacy waste from the initial shutdown, the likes of pool debris or the resins. So CNL estimate that in the coming 8 years, we'll have 20 shipment of low-level radioactive waste and 1 shipment of intermediate level radioactive waste that will be generated and safely transported to the Chalk River Laboratory for safe storage. One thing to note, while it's not part of the license period to decommission the spent fuel canister area, we do have a long-term plan for the high-level waste, which is the stored spent fuel that we have stored in that area. So the Nuclear Waste Management Organization has the mandate to develop a long-term solution for the management of all the Canada's spent fuel, used fuel, and Douglas Point's fuel would be transferred to this facility as it becomes available. And I would like to turn it over to my colleague Joe Holstead for introduction and also describe the Douglas Point decommissioning work that we've done. Joe?
Thanks, Julie. I think you covered a lion's share of it, but I'll do my portion here. So I go to the next slide there, Rachel. Okay, I'll talk about some of the work that we've done on site. And some of our projects are supporting storage surveillance, and to help prepare for future decommissioning. So we have a big focus of ours lately has been electrical isolation and a new electrical distribution system. So we took out our old power system and installed the entire new one. And on the bottom left picture, you can see those big green cables. So all of our live power in the facility is now green cables, which provides nice, clear identification of what's live and what isn't live. It helps for all sorts of work over the plant. We reconfigured our fire detection system. It's in the middle picture just shows an example of one of the panels. We've been doing asbestos abatement all through the non-nuclear buildings and have begun in the service building as well, which is classified as a nuclear building. And we have begun assessment of a fuel transfer tunnel. So there's a tunnel that runs under our service building, and then there is known active waste in that tunnel. And so we basically have drilled a couple holes into that tunnel to investigate and get some readings and get some samples of that waste and what we found in the tunnel. And we're planning for that waste removal to help plan for it and schedule that later. The next slide. Hey, some other things to help support the facility. So we have we're performing a project to upgrade our sump pumps, which were quite old. So there'll be new pumps and new control panel for that. We we're repairing the reactor building roof, as you can see there on the middle picture. Some damage from birds. And lastly on this slide, the cranes. Especially the reactor building main crane was taken out of service many years ago. We need that in service. We need that working to continue the last remaining waste removals in the reactor building, and to facilitate decommissioning of the internals of the reactor building as we move forward. So that it's being assessed this year, and the repair is going to happen next year. Next slide. Okay, so some of the bigger, some big activities around the non-nuclear buildings. So I mentioned, we've been electrically isolating also from water and fire water and all sorts of items like that. So those buildings are quite old and have many different owners. So just to confirm that there was no other lines or things we didn't know about, we dug a trench around the entire building, basically down to bedrock, and confirmed that we have cut and air gapped, as we call it, all around the facility, so that we can safely begin the demolition activities on the admin building, the turbine building, which Julie pointed out, and there's a small carpenter shop stuck in there as well. And as well as the steam bridge, which you see in that center picture, which connects the turbine building to the reactor building. So those are the steam bridge will be coming down this coming year, and the turbine building, admin building will all be coming down in the next 2 years. Just prior to that, we'll also be doing the final asbestos removal in those buildings. And you can see on the rightmost picture, sort of just my crude labels of turbine, admin, and ancillary facilities from the opposite end. That's kind of a picture from the other side of the facility. Go to the next slide. Okay, and then for the nuclear buildings, we are planning, we're getting ready with some design planning for demolition of the service building, the purification building, and the resin tanks and vaults. So the purification building, you couldn't really see it on the pictures, because on the diagram on the right, you see it tucked, kind of tucked in between the service building and the reactor building. A little square beside it is the resin tanks and vault, to kind of get you oriented with what we're talking about there. Go to the next slide. All right. The other thing we're getting into in the we got into last year, we started planning, and we'll be executing over the next year, is characterization of all the internals of the reactor building. As you can see in the right and the left picture there is quite a bit of equipment and systems in the reactor building. So we have a plan. We developed a plan for this one. Over the summer, we'll be executing the sampling and the scoping of all that equipment to help us plan for the decommissioning of the RB internals before we progress. Okay, next slide. We have a separate team. So that was the internals, but there's also the calandria itself. There's a separate team that is been doing work to characterize that. They've been using quite interesting tools, such as the you see on the top picture is the crawler that they used. There's a picture on the left there, the kind of the work area and some of the PPE and C that they had to wear in that area, and in the bottom right, some of the pictures of the equipment that was taken by the crawler. So really interesting work there to get ready to to begin planning the removal of the calandria and the reactor components that are still there. Okay, next slide. Oh, and so that's it. That's in a nutshell the major projects. There's this, smaller projects that are going on as well, but that's the most of it there. Questions?
Thanks, Julie and Joe. Sorry about that. I lost my mouse there on the screen for a second. Fantastic presentation, and we do have some questions coming in, which is great. So I will just give people a second to think about it, and then we'll get started. Okay, so one of our questions coming in was on the intermediate level waste being generated or a result of the decommissioning efforts. So the question was about the NWMO, and you know, we do like our acronyms here. So just as a reminder for everybody, NWMO is Nuclear Waste Management Organization, and so the question is about what CNL's preference is for IWL. So we won't get into that. There's a lot of information on the NWMO website about their consultation efforts for the Deep Geological Repository. And their kind of proposed solution for intermediate level waste. But I will throw it over to Julie and Joe if they wanted to talk about the intermediate level waste from the Douglas Point facility.
Sure.
We did touch on.
Go ahead, Julie. I think you addressed in your slide, so you can probably speak that too.
Sure. So for the intermediate level waste, while the NWMO is looking into a long-term solution and a disposal of this type of material, at this point, CNL's planning to send their ILW to the Chalk River site for safe storage, where we have a waste management area that can support that type of waste.
Thanks, Julie. The next question is, what is the estimated service life for the spent fuel canisters?
Okay, so the spent fuel canister area has a design life of, I'm going on top of my head, I think it was like 35 or 50 years. So that's not really a good timeline for you. But what I can mention is that we do annual inspection of the spent fuel canister area to make sure that it is maintain its integrity. And also we do have like 5 years more in-depth maintenance of the structure, assessment of the structure, where we really go into details to make sure that it stays safe. And once we are closer to the timeline of the design life, we have options of what we will do with the spent fuel, and one of which would be to extend via like a really comprehensive study of the structure to increase the longevity of it.
Thanks, Julie. Next question is, what proportion of the concrete is expected to be clearable as opposed to low-level radioactive waste?
So once again, I don't have the exact number, but it is a large portion. We need to understand that these structures are about a meter in depth. So during decommissioning, what we do is we do characterization of the surfaces that would have been potentially contaminated, and we will remove those. We do segregate all what is contaminated or low-level waste and what's clearable to really minimize the amount of waste that we're going to generate that wouldn't be clearable. And once again, we do have those values. It's in the 90%. I don't have the exact value, but
it's like 99%.
99%. There you go.
Even more than that, like because even when we do find a contaminated surface, we'll scabble it or shave it and then just dispose of that. Then everything else becomes can become crumbled and become fill.
Correct. Thank you, Joe.
Thanks, guys. Another question, is there a fuel bay that needs to be decommissioned?
Yeah, I can answer that one. Yes, there's two. They are in the process of being characterized actually now. There's a team that's going down there to characterize them, And yes, they are within the scope of our detailed decommissioning plan, and we will be, they are certainly included.
Yeah, they're part of the service building, so they will be captured in the work that we have submitted to for approval for the CNSC.
Awesome. Lots of questions coming in now. This is great. Okay, so why remove the non-nuclear buildings? And just while we're on that thought, is there a temporary facility for staff to shower and change down at
Sure.
Douglas Point?
Sure, I can take that. So our mandate is to remove this, like to remove all the buildings, I think as Julie pointed out at the beginning. And by removing the non-nuclear buildings now, it frees up the space around the reactor building and the nuclear buildings to then attack those buildings and proceed with the demolition there. So it very much makes sense that that is the flow that we have there. Now, as far as temp facilities, we do have a trailer set on site. We do have a shower and a bathroom trailer as well, and our trailer facility. So we manage that all through portable trailers.
I just wanted to add that the non-nuclear buildings, while they are non-nuclear and we could think that we want to reuse them, they are quite old and they require a lot of maintenance to keep them either habitable or just in a safe condition. So that's one of the reason. Also, it is a cost saving to get rid of them. They're no longer they're no longer useful for us. Yes.
Thanks, guys. Okay, another question. Low-level materials to Chalk River over 8 years. Could you provide an approximate end date? So, Julie, maybe it would be helpful just to highlight the timeline. I can pull the graphic back up if that's helpful too.
Sure, if you don't mind, that's fine. So over 8 years, which is the scope that we have approved as per our license right now. So it's the non-nuclear building, the service building, the nuclear buildings, and the reactor building clear out. So what was the question again? Over 8 years?
Could you
Does
provide
that?
an approximate end date?
Oh, end date of the entire project? Right now is 2070 because we do have approval in our license to proceed with the 3 first planning envelope, like I mentioned. And then we have to sit in front of the commission and propose our plans for the reactor core, the reactor building, and the spent fuel canister area. So that'll be our license expire in 2030. So we will have to sit in front of the commission, the CNSC commission, to extend our license, and at which point we'll determine our plan and our end date for those 2 outstanding package planning envelope. I hope this answers the question.
Yeah, and if we didn't answer the question as the person had asked it, you can always email us at ermstakeholder@cnl.ca, and we can definitely get you the information that you're looking for. Or if you want to clarify your question, you can also do that. Pardon me. Okay. Is there a plan to send the Calandria to Chalk River?
So the calandria is, once again, outside of our license period. The calandria is part of the reactor core and bioshield. So the plan as to where the calandria is going to go right now, like Joe mentioned, we're doing some characterization of it to understand exactly where we stand with regards to managing that waste. So those plans are not yet firmed up, if I can say. We're working at establishing those plans. We do not have permission to remove or start decommissioning of the calandria.
Thanks, Julie. Do you have a temporary facility to support breathing air as your staff may be in plastic suits at the reactor building?
Yeah, I'll
That's a
take
good
that one.
question.
Yeah, it's quite astute. So we have for breathing air, what we do is we use a portable cart and supplied plastic suits because yes, there is tritium hazards still within the piping. So we basically have a mobile cart that we use for that.
And since we're talking about the reactor building, somebody's asking what kind of radiation levels are there?
I hate to give the answer depends, but
Yeah, it depends of
you
where.
know, it goes anywhere from, you know, if you're talking about the very highest level, I mean, we're just getting a sense of that now as far as the you know, the reactor building phase. So I can't give you a good answer on that, but I would say you know, our biggest radiological hazards out there tend to come in the form of, you know, held up material, like heavy water held up in lines and stuff like that.
Mhm.
Not as much radiological fields, except with the exception of the calandria itself.
Calandria.
Yeah.
But we can stand in front of the calandria for periods of time without getting any
Yeah.
amount of considerable dose.
Yeah, in the past, oh, sorry, I just saw a mess there. Yeah, in the past they were quite high, but it's died up quite a bit. For
Yes.
example, we did the resins 3 years ago now, and where they had been at, you know, I think many hundreds of rem, they went down to like millirem, like 20 millirem at that.
Yeah. Yeah, the facility was shut down for over 30 years, so decay of material has reduced the dose quite a bit.
Thanks, guys. And we did get a clarification on the question on the timeline. So Julie, maybe I'll pass this back to you. So low level material has 20 shipments over 8 years. Is the end date for those 20 shipments 2070 or earlier?
The end date of those 20 shipment will be by the end of the 8th year. So those 20 shipment will be during it's for the work that we're doing right now. And as we generate waste, we do not accumulate it. So we would ship it to processing facility, size reduction facility, and then put it into Chalk River to for long-term storage.
Okay, thank you for clarifying that. And thank you to the participant for clarifying your question.
Thank you.
Okay, so will CNL be coordinating with trade organizations to establish the required workforce for this decommissioning phase?
Okay, so we work through contracting partners, and then the contractors work with the trade organizations. So we don't work directly with them.
Thanks, Joe. So we did have a couple of questions about the cost and budget for decommissioning for Douglas Point. So I don't know if we want to get into that in the webinar unless Julie and Joe are comfortable, but we could definitely look into it and provide some responses in our follow-up. Unless Julie or Joe, you wanted to speak to that.
It's hard to go get into the budget stuff right now because, you know, do you want it with escalation? Do you want it with you know, and also we're only sanctioned to 2026 and then we're going for re-sanctioning. So it's really hard to give a good number on that. And I'd have to just check what else we're allowed to say publicly as well.
Okay, so we'll take that away, and like I said, we'll follow up with the participants of the webinar. Is there a facility at Douglas Point to characterize alpha emitting radionuclides before waste is shipped to the Chalk River Laboratories, or is that done at another offsite location or other offsite locations? So before it's shipped.
So before we put things on the road, things have to be characterized. So where we would not have necessarily all the facility to characterize for every nuclides, we do take samples that are sent into labs for us to understand what's the material that we're putting on the road.
Yeah, and so maybe just to add to that, so say you have a system or a piece of waste, very first thing you do is you scope that. You use the handheld instruments, basically get whatever information you can. And then as Julie's pointed out, the next step is you take a sample of that item and then you send that to a lab and they give a more detailed breakdown of what isotopes are concerned. And BioShield's made out of concrete.
Thanks, Joe. That was one of our last questions. So you answered that. Thank you. A couple of last minute questions coming in here. So how will the ILW waste be packaged and shipped? Will there be any size reduction of the ILW prior to the shipment?
Okay.
Go ahead, Joe.
Sure. So it's hard to tell you exactly how it's going to be shipped. It's going to be air packaged because it'll have to be, depends on the item. But it'll be an approved transport casks. As far as size reducing on site, there will be some, especially as we segment parts of the system. We do anticipate, or we do think that will be size reducing, especially as we try to remove the components, and they'll be removed in such a way that they'll then fit into the shipping packages that will be then sent to Chalk River, where they may go into another package for long-term storage. So.
Awesome, thanks. Okay, and we did have a couple of more questions about the NWMO DGR. So I did just want to mention that the consolidation of AECL-owned waste, including intermediate level waste, the plans for that they're outlined in CNL's integrated waste strategy, and we did have a webinar on that. Sean Gamley gave a great talk and walked everybody through the CNL's updated integrated waste strategy, IWS, in one of our previous webinars, and it is available on our YouTube page if you want to go check that out. If you had any other questions about us, you can email us or go to the NWMO website. You can also review the released draft report on Canada's integrated waste strategy for radioactive waste, and that's available publicly online. Okay, so lots of great questions came in. Our Q&A is empty right now, but like I said, if anybody has any questions that they think of later, you can always reach out to us at ERM Stakeholder, and we'll be happy to answer your questions. Okay, if there's nothing else, I'd like to thank Julie and Joe for their time, as well as everybody else who supported the webinar. And I'd like to thank everybody who participated today. We do have another webinar coming up from 10 to 11, and it's on CNL's future waste capabilities. So
thank you so much.
Yeah,
thank you.
Thanks for the engaged questions too.
Yes, that was great.
Thanks very much, everybody.